When to choose SLS versus SLA 3D printing technology. We'll go ahead and kick it off. I'll go ahead and start with just a quick introduction on myself. I'm Levi Smith. I'm the Senior Channel Sales Manager over at Formlabs. I get to work very closely with the likes of MLC CAD and the rest of our channel ecosystem. And MLC CAD is someone I was really excited to get the opportunity to work with. If you look at the brand that is MLC CAD, what we're looking for at Formlabs in this channel is someone that can extend our reach into specific market segments, verticals, regions. And, the MLC story, obviously, for everyone on the call, everyone has a good feel for it, but I mean, they've been around for decades, tremendous service, and really, an added benefit to that is the portfolio of products they offer, right? You take that experience, you take that understanding, and really all you have to do to come to MLC with is a engineering problem, right? And they're going to come with an agnostic approach to solving that problem that you're running into, hopefully coming to a solution. Maybe it's Formlabs, maybe it's not, hopefully it is. But nonetheless, this is always what we're looking for. Someone that can extend our reach into the market with a very agnostic approach to solving engineering problems. And an added benefit to that is when you get to work with a company that's been around for as long as it has, and of course, at the same time, the tenure over at MLC CAD, right? You're dealing with the same people on a regular basis. Average tenure is like 7 years. It's really great to see that. To me, it means they have an excellent culture, a culture that keeps and retains its talent. And so you're always working with the same folks who know what you guys are dealing with on a day in, day out basis. Really excited to work with MLC CAD. And so I want to just put that in there as well with my introduction. Again, really excited to be on board with them and really excited to be working with some of the folks who might be interested in Formlabs on this call. So that's who I am. I've been with Formlabs for 5 years, and really excited to kind of just talk about the difference between SLA and SLS. So we'll go ahead and get started here. So quick agenda, right? We're going to do introduction on Formlabs. We'll do an overview on our SLA products, SLS products, our materials. We'll get into the use cases of SLA versus SLS. We got some great slides on that. And then, of course, some user stories, right? Why do people bring this technology in-house? What has it done for them? And then we'll finish up with some Q&A at the end. So that's kind of what we'll run through today. We'll go ahead and get started with an introduction, right? So if you think about our product line, there's two types of technologies we work with, and that is Stereolithography, SLA, or Selective Laser Sintering, SLS. You can kind of see on the bottom of the screen there just some good kind of stats on who Formlabs is, what we're about. This technologies, these two types of technologies, are not new. They've been around for a little while, but Formlabs has taken these and really put them in the hands of as many people as possible, right? What our goal is at Formlabs, our central thesis, if you will, is democratization. How do we make it easy for everyone to create what they want to create? And we do that through these two technologies by asking two specific questions. First one being, how do we make it easy? How do we make SLA and SLS easy? And we do that in two ways. It's easy to use, right? It's easy to get set up. You don't necessarily have to be a technician or have 3D printing experience to use our products. If you're looking at, let's say the Form 3 on the screen there, it takes you less than 30 minutes to get set up and start printing. Most of our users have little to no 3D printing experience before using our SLA or SLS products. So it's very easy to use, it's easy to afford. The second question that we ask ourselves is, how do we make it versatile? And in 3D printing, versatility is really equates to the range of applications or the range of materials available with the technology that you're printing on. And that's something we've really focused on. So whether it be SLA or SLS combined, we have over 40 different materials to choose from. And it really runs the gambit from, something that is more polypropylene-like to something that is more, like a nylon 12, nylon 11. It runs the gambit. So how do we make it easy? How do we make it versatile? That's what Formlabs does with SLA and SLS. And you can kind of see on the screen there, what that's kind of brought to the market, right? We've shipped over 100,000 printers. We've made over 100 million parts. We've grown to a global organization. I've been here for 5 years. It's been a blur of excitement. But I just wanted to make sure we had that quick introduction on who we are. So we'll get into this technology as we run through, right? SLA versus SLS. So we'll start with SLA. And what you see on the screen there is just the evolution that we went through. I touched on earlier the Print the Legend, the Netflix documentary. it really talks about the initial onstart of 3D printing, the hype that came with it, right? And we were really there as well, right? Our founders love this technology. They came out of MIT. They got a chance to interact with SLA technology. One thing they thought right off the bat is not enough people have access to these types of tools in their fabrication, and they went to work, right? So that's when they built the Form 1. It's an inverted SLA printer. They built it in the basement, put it on Kickstarter, hoping to raise a couple $100,000 from a couple of, 1,000 engineers. Within the first 30 days of the Form 1, they had raised $3 million. There's about 2,000 orders, right? And that's when we knew we really caught something. There really was a need for this technology out there. So that's the initial starting point for us in 2012 with the Form 1. Again, it's a desktop inverted SLA machine. And you see us really kind of iterate on that over the years, right? From 2014, 2015, the Form 2 came out. This really extended the range of our products in various verticals. And then we actually iterated on the inverted SLA process. We created a process known as LFS, which we'll get into on the presentation. And that's when you see us move to the Form 3, 3L, the Form 3B, the Form 3 plus, 3B plus. Again, these are all iterations, but quick just distinction, the 3B is our medical printer, right, for biocompatible applications or applications that require biocompatible materials. So just want to make that quick distinction. But again, inverted SLA, and then obviously we iterated on that, created LFS. So that's kind of the evolution on the SLA side. The reason we chose an inverted SLA process, if you look at SLA traditionally, before we came onto the market with our Form 1, it was a right side up SLA process, right? And it was cumbersome. It was tied to a very large industrial machine, so it needed a lot of space. It was a large capital expenditure right off the bat. And there's a lot of benefits to inverting the process of stereolithography, right? Low cost, you still get a lot of the performance and detail you're looking for. You're not wasting any material. I've seen some of these big industrial machines, you got to fill up a vat with, $30,000 worth of resin, or it's just, you can't really change over materials, right? With us, it's more efficient. And we'll get into that, but that's why we chose an inverted SLA process. So I just want to do a quick introduction on that. We obviously iterated on this process through our growth as an organization, and we created what is called low force stereolithography, or LFS. So if I think about an inverted process, right, it's more efficient. It does create a bit more peel for a bit more force between layers, right? So there's a lot more peel force as you build layer by layer upside down. And so low force stereolithography is what we created to kind of eliminate some of that peel force. And it's important in a couple of ways. I think the first way is it's going to create more robust parts, more smoother surface finish. It's going to create more optically clear parts with certain materials that we have. It's a high fidelity part is what you get on the other side of LFS. I think the second benefit, of course, with regards to low force stereolithography, is you get to build bigger. And so we're not only doing a desktop unit, we're actually doing a unit that's 5 times as big in the same way with LFS. And we'll touch on that. But again, this is the iteration we did on this. This is the engine that our technology currently runs on the SLA side, so low force stereolithography, or LFS. So just some of the benefits here: high resolution, fine detail, wide range of materials. It's easy to use, and the range of applications runs the gambit, right? When you're able to make an easy to use and versatile platform, applications expand exponentially. So whether you're prototyping, just doing some fit, form, and function testing, maybe some concept modeling, short run productions, tooling, manufacturing jigs and fixtures, it runs the gambit, right? What we do here at Formlabs really well is we make a very easy and versatile platform for people to use and build those applications and really do what they need to do. So just some of the benefits of SLA. If we think about the workflow, and this is getting back to that first question at Formlabs, how do you make it easy? We don't just look at the printers, right? We look at the whole ecosystem that you need to get to a finished part with SLA. So whether it be our preform slicing software, to our printers, to the post-processing that you need to do with SLA, with the the IPA alcohol bath that you wash the resin off, or the curing process, right? We think of how to make it easy in terms of the ecosystem to get to a finished part. So whether you're using our preform slicing software, using our printers, using our form wash or form cure, we want to make those as easy as possible. And so that's really the 4 steps you go through with a SLA product workflow. You got to produce the file, drop it into the slicing software, set up with the right support structure to print the part, drop it into our printer, obviously hit print. Once you pull that model off, it's got to drop into an IPA alcohol bath to wash off all the residual resin. And then finally, obviously, you want to do a post-cure in our form cure to make sure we get the final mechanical properties you're looking for. So that's more or less the process. If you think about the printers themselves, the Form 3 Plus is our desktop solution. It is powered by LFS. But pinpoint precision, we have what is known as the LPU, or light processing unit, that houses all the optics associated to building those SLA parts. It's a very modular machine, so these LPUs you can actually switch out if you have any concerns or issues with that optics unit. There's a series of integrated sensors on the printer, and it's very user-friendly. So if you want to set it up in your lab, work from home, you can drop files into that printer, start printing remotely. It's a very user-friendly experience when you use our printers. And again, with Formlabs, from the second you receive this machine to when you start your first print, on average, it's about 30 minutes. So it's very easy to get set up and start running with Formlabs on the desktop side. The Form 3L is essentially the Form 3 in a large capacity, right? So the build volume on the Form 3L is roughly 5 times what it is on the Form 3. We did this when we were initially building these machines. We were thinking about, well, how important is it to build large SLA parts? So you pull the data together, and what we really saw is the build volume that you see on the Form 3L is roughly 80% of all SLA needs that you see out there. So whether you're building large or whether you're building a small production run on small parts, you have a terrific machine. We pulled this data from 3D Hubs. Essentially, that build volume covers 80% of the market for SLA applications. So again, it's our large format SLA printer. It houses 2 LPUs as just one, again, 5 times the build volume, and a lot of the functionality that you see with the Form 3. So integrated sensors, it's a very easy printer to use, even though it's 5 times the size. As I mentioned earlier, there is a post-processing aspect to using SLA. So each SLA print that you pull off our printer does require an IPA alcohol bath. That's what you see on the left there. That's our form wash. Essentially, what you have is a build plate that you take off the printer, you put it right on the form wash, it drops in. There's an agitator or an impeller that agitates alcohol around the part, so it washes all the residual resin off that part. Once you do that step, the final step is a form cure, and that's what you see on the far right, essentially to get some of the mechanical properties you're looking to get, or just really get to a finished part. So form wash, form cure, those are the back-end post-processing units for the SLA side. And we have 2 versions of this. We have the form wash, form cure for the Form 3, and then we have a large Form 3L wash and cure. So large wash and large cure for the large Form 3L. Perfect. Okay, so on to the SLS overview, selective laser sintering. So Formlabs, again, for us, we're really focused on a couple specific components here, but selective laser sintering uses a higher power laser to precisely fuse plastic powder into lightweight, robust parts. So more or less on the SLA side, you're working with a liquid resin and an optics unit to cure that layer by layer. On the SLS side, you're using essentially another laser, but you're working with thermosets. So you're working in the thermoplastic range. And essentially what you're doing is you're heating up that powder to a specific temperature, and then you're using that laser to melt layer by layer. And in terms of what that looks like, just to give you kind of a rough outlook, this is more or less the process, right? You can see just a good live example on the right, but again, we're raising the ambient temperature to a specific level, and then we're using that laser to essentially push it over the hill, if you will, and melt that layer of powder. And we recoat it, and we do it over and over and over again until you have a finished part. There's a lot of benefits that we'll get to with regards to this, but I just want to give you guys just a quick introduction on what is SLS. And this is all powered by our Fuse One Plus. So this is the printer that we use, that we house on the SLS side. It's our flagship product, of course. And I think one of the things to keep in mind, one of the key benefits here is we have a 30-watt high-powered laser that really is the driving engine within the Fuse One Plus. But there's a lot of benefits to using SLS versus SLA. We can talk about, in 3D printing, the freedom with which you're able to produce in terms of the geometry. I think you're going to see that kind of standard throughout a lot of the technologies we offer. But an added benefit to the SLS side is that it's unrestricted with regards to having to build around support structures. With SLA, you do have to build support structures around that part so it builds properly. And then that's added to the post-processing side of it, right? So you still have to clip off all those support structures. On the SLS side, you don't necessarily have to worry about that. The powder that's laid layer by layer actually self-supports the part as it's being built. So once you build your part, all you have to do is dust off all the residual powder, and you actually have that final part. And again, it's a UV stable part, right? On the SLS side, we're working with a lot of the standard thermoplastics out there, nylon 11, nylon 12. We also work with some elastomeric materials, so we offer a TPU as well. So whether you're using nylon 12, nylon 11, we have some iterations on that. We also have flexible materials. Again, it's a UV stable part, and it's really great for low volume production, but just a couple of the significant benefits that you get on the SLS side, if you will. So touched on this, excellent mechanical properties, great accuracy, no need for support structures. It's a production ready printer, and we'll talk about this in some of the case studies at the end of this call. Applications runs the gambit. Again, we have over 5 materials available on the SLS side, but in-use parts, bridge production, fit, form, and function prototyping and testing. It's going to build a long-lasting, durable part. So it's great in the manufacturing, tooling, jigs, and fixtures. It really runs the gambit on these two technologies, and it's all tied together with what we're trying to get accomplished, which is how do we make it easy? How do we make it versatile? And so we'll continue to touch on that as we go through on this presentation today. Again, workflow, very similar to what you see on the SLA side. Once you have a 3D file ready to go, you drop it into our preform slicing software. Again, preform or our slicing software is the same on both the SLA and SLS side. You just have a drop down where you change from SLA to SLS. But you prepare the model in preform, drop it into the Fuse, and then obviously you sift the print or post-process the print on our Sift printer, or Sift post-processing unit, which I'll touch on at the end here. The 3D software is very user-friendly. I do recommend, if you guys get a chance, to talk to MLC CAD, take a short demo of what this looks like. But again, whether you're using our SLA or SLS technology, it's very easy to use. And it's a specific set of, there are some nuanced differences between printing or preparing an SLA versus SLS. But there's a lot of very useful features, right? You have a one-click print mechanism where you can just hit one-click print, it'll orient your part, set it up to be printed. We have auto nesting features, but it's really built to reduce a lot of the preparation time associated to getting your model ready to be printed. So that's step one. In terms of the Fuse One printer itself, just want to give you a quick rundown. Again, industrial materials, very reliable, consistent prints. It's a very accessible technology, so you don't necessarily need a capital expenditure to afford it. We have a very, very robust system with regards to getting a high ROI on a cost per part analysis on the Fuse One side. So, with the material that we use per build, we're actually able to recycle it over and over again. So you actually have a sintered part itself. So it's very recyclable in terms of the material. So you're not throwing it. There's not a lot of waste with regards to unsintered powder, and it does create a very low cost per part, but it's also got a very high throughput as well. So we'll touch on some of that in some of the user stories here. The Fuse Sift, which is the complement to the workflow, it's the back-end post-processing associated to SLS, because with every print every build that you do have to dust off and get all the residual powder off that part before it's ready to go. And the Sift is a key component to our printing ecosystem on the SLS side. So the fuse has two responsibilities. One is obviously to dust off and post-process, get all the residual powder off that part. The second responsibility is to mix the powder. So it holds two bays within this, which is both our new and used powder. Each build on the fuse is a mixture of both new and used powder, so it's going to mix the proper ratio of powder. So for us, it's standard on average about 70-30 used versus new powder. But it's a very simple workflow. People are really worried about a powder-based system in their work environment. If you look at kind of the screen here and kind of the top part, it's a negative pressure environment, so you can actually reach in there, dust off your parts. You're not going to push dust, our powder into the air, into your office environment, and we got some great data to kind of back that up. But I've seen these in garages, in labs. I've seen them in WeWork spaces, right? It's a very compact, easy to use workflow. You don't have to change your environment a whole lot to work with a powder-based system. And there's a lot of data, a lot of details to get into on that, but it's very easy to use, I guess is really what I'm trying to get at. So simple, compact, very efficient in terms of recycling and dispensing, very much a crucial component of the SLS process. So that's SLA, that's SLS. We talked about, kind of what these printers represent, how do you set them up? How easy are they to use? We'll talk about the range of applications. What is the range of versatility with these machines? And as I touched on earlier, we have close to 40 materials. And with our printers, it's easy on the SLA side to seamlessly move from one material to another. So for example, let's say I have a 2-hour print on the SLA side. I could go through 4 iterations of that in a day's time with 4 different materials, because the changeover from one material to the next is no more than 5 minutes. So I did want to touch on that with regards to SLA. It's very easy to change over materials, and the range of materials is substantial, right? So you have both, this is the SLA Material Library. You have our standard general purpose resins. Our rigid resins are really exciting in the automotive and aerospace industry. This is the glass filled rigid material. So you have a rigid 4K, rigid 10K. You have materials that are polypropylene-like, so are durable, are tough, our tough resins, so our tough 2000, tough 1500. We have elastomerics, so our flexible 80A, our elastic 50A. We have some specialty resins, so high temperature for high heat deflection. We have an ESD material, and then we have a whole suite of biocompatible materials. So our Biomed Amber, our Biomed Clear. Obviously, you have our dental category, our jewelry resin. So it really runs the gambit in terms of the range of applications you have on the SLA side. And you do get the same effect on the SLS side. So in terms of the powder material library that we have, you have our nylon 12 glass filled, nylon 11, and then obviously our nylon 11 carbon fiber. And you get a good feel for kind of what you get accomplished with these materials on the bottom of the screen there. So nylon 12 tends to be our bread and butter, right? It's general purpose, industry standard for PBF. It's great in jigs, fixtures, and tooling. Our nylon 12 glass filled is great with regards to sustained loading. It's great for threading applications and sockets. Nylon 11 tends to be great for impact resistance. You can still get away with a lot of thin-walled parts with that impact resistance. And then we're starting to see nylon 11 carbon fiber on the automotive side. So lightweight parts that are still robust and strong is really what we're seeing with our nylon 11. And last but not least is one of our newest releases, which is this year, and that is our TPU 98 powder. So again, our first elastomer on the SLS side. Again, great for soft touch elements, wearables, gaskets, seals in the automotive space. We see this on the consumer device space as well, right? Protective sports equipment. It's great in the O&P market. It really runs the gambit, right? So the range of materials right now on 12, nylon 11, variations of those two, and then of course, obviously an elastomer as well. So whether you're looking for something that's flexible, tough, strong, polypropylene-like, ABS-like, it really runs the gambit in terms of what you're trying to get accomplished. And as I touched on, we got a great avenue with MLC CAD here, right? So come to them with what you're trying to get accomplished from a material standpoint or material property standpoint, they're going to have an agnostic solution on the other side, and they got a range of applications to choose from, or a range of materials to really help you solve that engineering problem. All right, so just a quick summary in terms of when to think about SLA versus SLS. I like this slide here, just talking about just a quick range of the benefits and obviously the range of applications. So SLA, right, high resolution, high fidelity, fine detail, wide range of materials. You just got a set of applications there, right? If you want to iterate on an idea to get to a final kind of part that you want to make, to, you know, if you want to do various molding prototypes or low run injection molding testing with rapid tooling, or if you want to, you know, just standard jigs and fixtures and specific manufacturing aids, there's some great benefits to using SLA there. SLS, again, great mechanical properties. You still get tremendous accuracy in the print quality. There's no need for support structures, so there's a little bit less post-processing, and it's very efficient for large production runs. It's really great in small production runs, and that's kind of what we'll run through in our case studies today. But, you know, in-use parts, functional prototyping, there's a great play there for SLS. So just want to give you guys a quick summary on the difference between those two. And then we'll step into use cases, right? And this is a slide I really enjoy in terms of talking about when to think about use cases specifically, right? So on the bottom of the screen, you have, you know, kind of the stream that we see SLA in, and then right below that, kind of the overlapping stream with SLS, right? You go from essentially the idea stage all the way to the production stage. Where do you think about SLA? What do you think about SLS? And this is what you really have, right? If you're really thinking about what is the final form of this thing that I'm going to make, right? Definitely think about SLA. As you get into fit, form, and function prototyping, and you get to kind of low volume production to high volume production, you want to start thinking about SLS. And that's why we really want to cover these two specific technologies here. So just gives you a range of applications, when to think SLA, when to think SLS. And then of course, you got a great group in MLC CAD to really help you on that journey. Perfect. So use cases and or user stories. We'll go ahead and get into these. First up is Dorman Products. So Dorman Products came to us. Again, this is a group in the automotive space doing a lot of OEMs or it's just an OEM in the automotive space, excuse me. But really what they're looking to do is bring 3D printing in-house, right? A lot of fit, form, and function testing. Currently, they work with our Form 3 and 3L on the SLA side, and these printers get roughly 12 to 18 hours of work every day, 7 days a week. So they'll actually run them over the weekend, do batch production, do batch post-processing, but originally brought us in for fit, form, and function testing. And we were kind of their initial foray into, should we just outsource our 3D printing needs and our prototyping needs, or should we bring this in-house? They tested that theory out with Formlabs. And what they found is the ROI was exponential, right? They're thinking maybe a 1-year turnaround on the ROI to bring this technology in-house. They got it within 2 months. And that's what really justified their journey into our large format Form 3L. So they're really covering a lot of ground with fit, form, and function testing. They're doing a lot of go, no-go testing as well. And they're getting a really quick ROI. It's really allowing them to expand the 3D printing footprint within their organization, just based on that. So again, very easy to use. I think the team had very limited experience before bringing Formlabs on. It has a huge benefit for them. And of course, the business outcome, they're able to justify it in 2 months, get into another machine. And now these machines have 12 to 18 hours of work every day within that organization. Next up is Xspector. So this is a group that's using both our SLA and SLS technologies. Think about that graph I showed you earlier from, you know, creating an idea to getting to low volume production. This is a great case study, a great user story on that journey, right? So this group right here, they use essentially what you have is a mounted tripod that is functional on the outside of your car. So they do a lot of essentially it's a tripod for infrared cameras. And again, you can't do that inside your windshield, right? So either you got to step out of your car or hold your camera outside the window. It's great in the hunting industry. And essentially, he wanted to fix and solve this problem. So, you know, he had an idea of how to build this tripod. He was using our SLA equipment at the time. So he had an idea of what he was going to build. But he started to look at what it'd mean to actually tool up and start producing these tripods in-house. And right off the bat, even if he got it right off the bat, it would have been a $100,000 investment. And that's when he thought about our SLS Fuse 1 Plus. So he's able to build these tripods in-house. It's about 40 to 50 parts to build that tripod. It's a mixture of both some durable components or our durable material for some threaded components. And it's a lot of our Fuse 1 kind of printing for the enclosures for that tripod. But he's able to produce these in-house with both SLA and SLS. And he produces about 1,500 a year, and he's able to really bespoke the process, right? One of the key kind of hindrances of building this tripod is the fact that there's new camera models coming out regularly. So if he had to tool up every time a new camera came out, he wouldn't be able to have this business. But with the SLA Form 3L and the SLS Fuse 1, he's able to actually iterate consistently, no matter if there's a new camera coming out for this tripod, or maybe there's just an idea in terms of making this tripod more efficient. He's brought the whole workflow in-house, whether he's just building the next prototype or producing the next run of tripods. So it's a really great story. I love it. Again, he thought about tooling, brought this technology in-house. Now he really controls all aspects of both the prototyping and the manufacturing of this. So I want to touch on that. Vital Auto, again, brings both our SLA and SLS components in-house, our printers. This is more or less a automotive industrial design studio that works with the likes of maybe McLaren, Nissan, Lotus over there in the UK. But again, they're constantly iterating on concept vehicles for these big automotive companies over there. And they have a very innovative approach. I think they have close to 15 of our printers, both SLA and SLS, essentially a monster print farm. And they're constantly iterating because these companies come to them to do something that's maybe never done before, right? And so they have a very innovative process in how they 3D print. As I touched on, there's 5 different materials available on the Fuse 1. They'll actually run each one of those machines with a different material, and they'll take specific component parts of this car and they'll run it across all 5 different materials in design sprints, right? What does nylon 11 feel like with this specific part? What does nylon 12 feel like? What would a TPU for a gasket feel like versus a nylon 12? They actually do design sprints in a very innovative way. And so it's very exciting to see what they do over there. Again, they're a very big proponent of Formlabs, both our SLA and SLS technology. In fact, they're using a lot of those SLS parts directly in their concept vehicle. Same with the SLA side of it. The final case study here is IBL Hydronic. So IBL Hydronic works with a lot of large, very capital-intensive agricultural equipment, and they really work in more or less the controller's cockpit, right? That's kind of their bread and butter over there. And these multi-million-dollar machines and the controllers that run them, they wanted to build a bespoke process for them to get more or less a control unit that was customized to them. So it's very bespoke, right? They'll bring someone in, they'll let them sit in the cockpit, they'll actually kind of work with them in terms of the ergonomics of how that chair sits, and then they'll customize a specific control unit for that user, right? And so what you see on the screen here is both our SLS and SLA technology together, right? So the buttons and the color coding there, that's SLA. The enclosure for that mechanism, that's done in SLS. And so they've really built a market around that, right? Bespoking this type of equipment for the specific use that they work in.
You had me at tractor, man. I always wondered on those machines that cost, $1 million and they have all these molded parts, right? How do they justify the cost of those injection molds when they're probably only selling, dozens, right? At most hundreds of those units, but it's got to have so much customization to it. And by doing it this way, in an additive way, customizing it for the operator, customizing it for the way the machine is configured with any additional functions, being able to add additional thumb buttons or something like that to exactly fit the operator and their needs, really could shave off a lot of time, right? Create some efficiencies for that user. So you're talking about a drop in the bucket in terms of the overall machine cost, but it adds a fantastic differentiator for you in the market and saves you a lot of money.
Absolutely. And some of these companies are, they're so innovative, they just don't have the ability to go tool up, right? And so, I mean, it's created a market within itself. And you have both a happy finance department, you also have a very happy customer, right? It's a win-win-win across the board.
Yeah. Plus, I find that a lot of these big heavy equipment manufacturers are much more comfortable designing a 1-inch welded plate part than they are an injection molded plastic curvy part. So
Indeed.
being able to do it, just kind of try it out and just iterate, and then use that technology to kind of fill in that void, because that's just not what you do. So anyway, that was awesome. I'm struck by the SLA and how many materials there are. Some materials that you don't really think about in terms of additive manufacturing. I'm also struck by the SLS, how it really speeds it up. There's almost no post-processing at all. You just take it out of the dust, and the Sift takes care of any mess. It's some really nice technologies. We're really excited to get our hands on them. We are taking delivery of our first demo units, so we're going to have some of these in Dallas and Austin and Atlanta, I believe. So definitely anybody in those areas, if you want to stop by and see them, let us know. If you want a sample part, you want to put your hands on this, let us know. We'd be able to get one out to you, talk about your needs, and see which material might be a good fit.